The sum of two numbers is 90. Many of you chose to do this. X plus y equals 90. And one number is 4 times the other. So if you said, say, one number is equal to 4 times the other, you could create 2 equations with 2 unknowns. If you do this, then, oh, but y is 4x. So you could say, and say that 4x should be the same as y. Some of you skip this step and just stayed with x and 4x. That's awesome. You just did it without the substitution step. And you get x plus 4x is 90. X plus 4x is 5x. X is therefore 18. And if x is 18, then what's our other number y? 4 times 18, or 72. Finding the measure of angle ABD. What is the measure of angle ABD?
180.
What's the measure of angle ABD?
180.
180. How did we know it's 180?
Straight line.
Isabel?
You add 168 to 12.
Because you add 168 to 12. The reason for its 180 is not because it looks like a straight line. I did not say that this picture is drawn to scale. There's nothing here that says this must be a straight line specifically. The reason why it's 180 is because the angle addition postulate. This angle plus that angle should add to the entire thing. Or 168 plus 12 equals 180 degrees. And 180 we know is called a straight angle. Let's see. The first 3 types of angles are the following. Complementary angles. A pair of complementary angles are the following. Complementary angles are a pair of angles whose measure add to 90 degrees. A pair of angles whose measures add to 90 degrees. Okay? 90 degrees is a pretty important angle measure for us in geometry and math in general. Complementary angles are any pair of angles. If you add up the measures, they sum up to 90. Okay? What's another incredibly important angle measure that we're going to use over and over and over again? 180. Supplementary angles do that. It is a pair of angles whose measures add to 180 degrees. Adjacent angles is a pair of angles who share a ray or side. Okay? So as a kind of first usage of these terms, let's find a pair of angles that are complementary, a pair that are supplementary, and a pair that are adjacent, please, and label them. Absolutely. This pair, KLJ and IHG, are complementary. The angles add up to 90. Supplementary pair. Supplementary.
IHG and MLK.
Angle IHG and angle MLK. MLK. 75 plus 105 is 180. Absolutely. Those would be a supplementary pair. And what's our last pair? What's an adjacent pair? A pair that shares a side. Angles, repeat that one more time. and you know two pairs are complementary and one is one measure. What does the second one need to be? Yes, in the back.
73.
Better be 73 degrees. 73 plus 17 is 90 degrees. Okay. What if angle 3 and 4 are supplementary? And 3 is 119. Greg, what does 4 have to be? Was it?
61.
Then angle 4 better be 61, or that number that adds with 119 to get 180. Okay? Complementary and supplementary. How about this example? What if two roads intersect and form supplementary angles? XYW, XYW here, and WYZ. Find each of those two angle measures. What are we going to need to do that? What do you think is something we could use? Joel?
Well, we can make an equation like 2x plus 14 plus 4x minus 20 equals 180 because they have to equal, the supplementary means it equals 180.
Combine like terms, 6x minus 6 equals 180. Add 6 to both sides. 6x equals 186. X is therefore 31. Don't care what x is, I do care what the angle measures are. So I'll plug 31 in for the first one and get 2 times 31 plus 14. 2 times 31 is 62, plus 14 is 76, or the measure of angle XYW is 76 degrees. Therefore, the measure of angle WYZ is 104. Two more. Our last two special angle relationships are the following. A linear pair. A linear pair is a pair of angles that are adjacent and their sides form a straight line. Or more specifically, we could write down that it's a pair of angles of adjacent angles whose non-shared sides form opposite rays. Vertical angles. Vertical angles are along the similar lines. Vertical angles are a pair of angles that are formed when two lines intersect. Now, a more formal way to say that would be a pair of angles, a pair of non-adjacent angles formed by two pairs of opposite rays. Angle 1 and angle 2 are definitely a linear pair. They share, they're adjacent, and they form a straight line with their non-shared sides. Yep? Angle 3 and angle 2 are in a linear pair, for sure. Angle 3 and angle 2 share a side and form a straight line. Are there any other linear pairs here, Anna?
Angles 2 and 5.
Okay. Angle 3 and 5 form a straight line. Are they adjacent?
No.
They don't share a side, so they can't be a linear pair. This one's, if you're not used to seeing these yet, they're, Joel, what's one pair?
Angle 1 and angle 3.
Okay, angle 1 and angle 3 are a vertical pair. Are there any other vertical pairs here?
3 and 5.
3 and 5. Are 3 and 5 formed by two lines intersecting?
No.
No, so they're not vertical. Are there any other pairs of angles here that are vertical?
Angle 2 and angle 4.
Angle 2 and angle 4. Angle 2 and angle 4. Are those formed by two lines intersecting? Nope.
Or could you make like a new angle like by combining 5 and 4?
If you were to make your own angle by combining 5 and 4, that would give you a vertical angle, yes. Because you'd have this line and this line. If you said, well, this was just one big angle, then that would give you a vertical angle with angle 2. But since we don't have that labeled, we won't jot it down. But yes, that would be... If two angles form a linear pair, what do you know about their measures?
They have to be 180.
They better be 180. Otherwise, they're not going to add up to a straight line. If two angles form a linear pair, that means that those two angles better be supplementary which means they better add up to 180 degrees. So if we said we had two angles, say, oh, I don't know, how about x and y? We'll get super creative here. We'll say their measures add up to 180 degrees. We'll even get technical and put in the measure of the angle symbol. Measure angle y. Measure of angle x plus measure of angle y better be 180 degrees. How does measure of angle x compare to the measure of angle y?
X is, or y is 3 times more than 3 times that, or x is 3 times less than y.
Sure.
That's a weird way to say it, but
Sure. We can say 3 times of x better be y. One way to write it. You could go the other way around. You could say 3 times of y is x. It doesn't matter. I mean, we're still going to get two separate numbers. So then you could plug in here and say that whatever the measure of angle x is, plus 3 times that same measure of angle x better be 180. And if that's the case, then 4 times whatever x is better be 180. So then what's the measure of angle x? X better be 45 degrees. So if x is 45, what's the measure of angle y? Better be, 45 and 135. Okay. Basic angle pair relationships. We're going to be using these throughout the year. As we come up across more and more angle pairs, we're going to be using them more and more and more.